All right, so we are going to take a look at graphing rational functions, and this particular lesson in our unit on rational functions is a little bit of a review from way back in first semester when we did our mother functions unit and we graphed rational functions. So hopefully this will kind of stir some memories in you, bring out some prerequisite knowledge. So I'm going to give you a minute or two to pause the video and go ahead and try the opener here and graph this rational function, and then turn it back on and we'll see how much you remember. All right, so let's take a look at this problem and see exactly what you remember. So the first thing we talked about is that every rational function in this form, and this is what we said was HK form, right? So f of x equals a over x minus h plus k, all right? And so we said the first thing we want to do is look at this h value, and that's going to give us a vertical asymptote. So in this particular case, notice it's x plus 5, and it's always opposite, so that means our vertical asymptote is really at negative 5. So I'm going to draw that vertical asymptote in. All right. Okay. And then what we said was the k value out here is going to give us a horizontal asymptote. And in this case, that would be negative 2. So I'm going to go to negative 2 right here. Draw that horizontal asymptote in, just like that. And then what we said is where these asymptotes cross is really kind of our new origin, right? And this is where we're going to graph our points from. Now, in our mother function, when we originally did our rational function, we said our normal point would be to the right one and up one. So right here is where we would have normally put our point. But we know that the a value, which is 3 in this case, affects how tall, all right, that point is. So instead of going up 1, I'm now going to go up 3 times as much. I'm going to go up 3. So 1, 2, 3. And then we said we know that that branch of the graph is going to come down the vertical asymptote, hit that point, it's going to turn, and then it's going to get really close to that horizontal asymptote like that. Now on the opposite side on our mother function, normally we went to the left one and down one. Now once again, because this a value is 3, all right, I'm still going to go left 1, but then I'm going to go down 1, 2, 3. All right, so it gives us a vertical stretch there. All right, and once again, it's going to follow the vertical asymptote this way. It's going to turn, get really close to this horizontal asymptote. All right, and so there's the graph of our rational function in HK form. All right, so hopefully this, if you didn't remember it right away, that's not really a big deal. We know it's been months since you've looked at this, but hopefully once you've seen this, some of this is starting to come back to you. Now, so let's talk about some key aspects of our graph here. All right, so where is this, the vertex or the center really? It's not really a vertex with rational function, but really the center of our graph is going to be that HK, just like what we got up here where those two vertical asymptotes, or excuse me, that vertical and horizontal asymptote crossed. All right, so where's the vertical asymptote going to be? All right, okay, that was at, right, x equals negative 5, right? And so we should put negative 5, negative 2, right? All right, so that's kind of where the center was. Now, domain, right? Domain is x, all right? And so the domain for this particular function would have been all real numbers except x can't equal to negative 5. So notice we'll get every x value to the right of negative 5. We'll get every x value eventually to the left of negative 5. So that would be our domain. And then we said the horizontal asymptote, this case, was y equals negative 2. All right, so those were kind of the key pieces, all right, that we want you to be able to recognize, especially in this form. Now, the challenge in this unit is eventually we will get to graphing rational functions that are not in HK form, and then we'll figure out how to do some of this then. So now, just a brief summary. So when we're talking about HK form, we get this, right? And just to generalize what we just did on this problem to our form here, the center of our graph will always be that HK value. The equation of our vertical asymptote will always be x equals h. All right, notice this is an equation, right? It's a vertical line. Okay, the domain will be all real numbers except x can't equal to that h value. All right, and if we were to put that in interval notation, it would look something like this, right? Okay, and then the equation of our horizontal asymptote will be y equals k, like that. So hopefully that's a really good synopsis of everything we did with this function way back in first semester. All right, so let's take a look at the next page here. All right, so what we want to do is just kind of go through and briefly, or not briefly, but hopefully quickly, graph these functions, finding these key pieces of information. All right, so when we look at number 1, all right, that vertex or that center, right, all right, would be negative 4, negative 6. All right, and the reason is because our vertical asymptote would be x equals -4, and our horizontal asymptote would be y equals -6. All right, so if I just sketch those in, you will see that we will get that new center, all right, just like this. All right, so there's our new center, right? That's our new origin, all right, is -4, -6. Now, the domain then would be, all right, -infinity to -4 union -4 to infinity. All right. All right, so now let's look at graphing our points. And once again, normally for our mother function, we go right one, up one. But once again, just like that opener, our a value is 3, so I'm still going to go to right one, and then I'm going to go up 1, 2, 3. So remember that a value only affects, all right, the y value. All right, it's a vertical stretch or a vertical shrink, depending on what that value could be. All right, and so now we get that this branch is going to come down that vertical asymptote. It's going to hit this point. It's going to turn and approach that horizontal asymptote, just like that. Now, once again, in the left side here, we normally would go left 1, down 1. But because of that a value now being 3, we're still going to go left 1, and then we're going to go down 1, 2, 3. And we don't get to see as much of this branch, but we know it's going to kind of curve and follow both asymptotes like so. All right. Hopefully you're feeling good about this. All right, now let's look at number 2, because number 2 is slightly different. All right. Now, we've looked at this with other functions before. All right. And I'm going to just pause for about 10 seconds here, let you look at that and see if you can figure out what's different and maybe how or what we need to do to work with g of x in number 2. Okay, so maybe you saw that in the denominator here, all right, we don't have like x plus 4, x minus 3. Now, we've talked about this in some of our other functions that sometimes to get it into HK form, we have to factor out a GCF, and that's really what we need to do right now. And notice by factoring out that GCF, it's going to affect our our H value, but it also could possibly affect our A value because maybe we get some things to divide out. So when I look at this, I'm going to have -3, and then I can see that I have a 3 as a GCF in my denominator, so I'm going to factor that 3 out, and that's going to leave me x minus 4 and then plus 2. And notice here's what I was talking about. Now notice, all right, I can see that my k value is 4. Assuming the h value is 4. But now notice I also get, all right, a common factor in the numerator and the denominator. So now if I reduce that, I get -1 over x minus 4 plus 2. All right, so factoring out that GCF does a couple of things. One, it could have an effect on the a value in the numerator. But 2, it allows us to see, all right, clearly see our h value here. All right, so now when we look at number 2, right, I can see that my vertical asymptote is going to be at x equals 4. All right, I can clearly see that now, so I'm going to draw that in, like so. I can clearly see that my k value is 2, so my horizontal asymptote is going to be 2. So let's draw that in. And once again, once I draw those in, I can definitely see that my new center, all right, is going to be 4, 2. All right, so now notice our a value is -1. And remember, that only affects our y value of our points when we graph. And normally I'd go to the right one and up one. Notice what this is going to do. This is going to reflect our graph over, all right, our horizontal asymptote, because instead of going up one, I'm now going to go down one. All right, and then our graph is going to be below the asymptote here and down that asymptote. And it's going to flip on the other side, because normally I would go left one and down one, but so the opposite of going down one is now to go up one. And so whenever that a value is negative, we're going to get, all right, a reflection of our graph over wherever our horizontal asymptote would be. All right, and then to wrap up the problem, once again, you can see that we get every x value, all right, except for +4. All right, so hopefully you're feeling good about graphing rational functions in HK form. All right, so now just real quick, let's take a look at going in the opposite direction. What if we were to reverse this process? What if we had the graph of a rational function, all right, and we now want to write the equation? All right, so the first thing that we really want to do is identify those two asymptotes, because that's going to help us find h and k. And then that's going to help us find our center, which will allow us to count our a value. All right, so when I look at number 3, hopefully you can see that we have the vertical asymptote here at -5. All right, so we can see that we have that vertical asymptote. So there's my h value. That's -5. And then when I look, it looks like our my horizontal asymptote is at -3. So I can draw that in. And I would advise you to draw that in. It's going to help you visualize it and see if you're off by 1, or if the graph crosses that. It should not in this case. All right, you can see all those things by drawing it in. And so we get -3 here. The other thing is, once I've drawn them in, I now know that this is my new center. So this is where I'm counting from. And when we go back to our mother function, we normally would go to the right one and up 1. And I can see that that's not the case. So I can see that I go right 1, but instead of going up 1, I go down 2. Well, that means my a value must be -2, all right, to get to that point. And so by identifying that center with your horizontal and your vertical asymptote, it gives you a good reference point to count from to find that a value. And now if I take all of that and plug it into my equation, there's my a value. And remember, it's x minus h. So since it's x minus -5, that becomes x plus 5. And then my k value is -3, so there is the equation of that rational function. All right, one more problem, all right, for this video. So once again, we have our graph of our rational function, all right, and we want to write its equation. All right, so now when I look at this graph, to me it looks like the vertical asymptote is at +4 here. So I'm going to draw that in. It looks like that branch is getting close to it. As we follow the branch on the left, it definitely looks like it crosses 3 and it's going to start getting close to 4. All right, so there's our h value. Now I'm going to look for my horizontal asymptote, and in this case it looks like it's at -6. I'm going to draw that guy in just like so. All right, so there's -6. All right, and so I can see that my center here, let me write that down so we don't forget. All right, and I can see that my center here is right here. And so now notice when I go to the right one, I have to go up 1, 2, 3 to get to that first point. So that means my a value is 3. And now all I have to do is just take those 3 values, put them into our equation. So f of x equals to 3 over x minus 4 minus 6. All right, so there's a brief review on how we graph rational functions in HK form, and then how do we flip that process and write those equations from a graph. So be sure to do your video check-in, and I will see you next time.